Hi everybody. Today I'm going to explain about our presentations smart grid and power system. Smart grid is an advanced electricity network that is used in communication sensors, automation and intelligent control system to improve generation, transmission, distribution and consumption of the electricity and the electrical energy. Unlike traditional powers grids, smart grids enable two-way of communication between the utensils and the consumers, making the system more renewable, efficient, and sustainability. Smart grids are important because they are help in reducing the outages of the fast fault detection and automation recovery. They improve energy efficiency and the monitoring electric usage and the real-time optimization distribution. The hardware required in the smart grid includes microcontroller like Arduino or ESP3 current and the voltage sensors, smart meters and delay modules, circuit breakers, transformations, batteries and solar panels. These components collect the electric current and electrical data monitoring system performance and the provide protection for the control functions. In the conclusion, the smart grids are transforming traditional power system to intelligence automation and the energy efficiency network. They enhance reliability, reduce operation cost, and support renewable energy integration, making a key technology for the future of the power distribution. Thank you.
I am Guru Prasad, and my topic is software stacks and tool chain. And I'm going to explain about the software ecosystem which are needed to run a smart grid system. And in this topic, I'm going to discuss by the some topics and included subtopics. And the first one is embedded and edge software. Their tools are like Arduino IDE, embedded C, MicroPython, and the functions that are going to be the firmware development and sampling signals and filtering nodes, running local control loops and watchdogs for reliability. And another one is the modeling and simulation. The keys that we means the tools that is MATLAB and Simulink, and the purpose of this content is simulate dynamic system behavior and test stability and validate control strategies and before deploying in the field. And third one is I would like to discuss the third topic, lot of platforms and databases. The platforms we are seen everywhere like ThinkSpeak and Blink and MQBB brokers, and the databases are like InfluxDB and time series like relation DBS. And about the main role about this topic, what is the lot platforms and databases are collect the telemetry, store historical data and enable analytics. And the last another one is analytics and controls. In these topics we are going to use the tools like Python, MATLAB and EMS, Scala systems, etc. In this we can see the functions of this our topic. There we can see the fault diagnosis and the load forecastings, automated dispatch decision. And the next topic I'm going to discuss about that, the control loop from the measurement to action. And in this topic we I'm gonna highlight how the smart grids close the loop between the sensing and the action. We're gonna look through the some step by steps. So first one is I would like to say measures, because they are sensors capture electrical parameters, and the next one is communicate, their data flows securely and quickly to analysis systems. And next one is analysis, because algorithm decide set points or detect fault. And next actuate, release breakers and inverted executes control actions. And I subdivided these topics related, and second topics I conclude I assign the design priorities. So first of all, we have to give priorities for everything, right? So for my think for a design priorities, I like low latency and high reliability, secure authentication, and deterministic behavior like prediction, consistency, responsible for some protection formulas. And another topic and I would like to discuss about that is renewable integration and storage. It is common, I think, everywhere. And this in this topic, I'm going to focus to tell on the focus on the handling variabilities from the solar and the wind power. We are very familiar with the solar and the wind power, right? And we will change we will face many challenges in these topics, like renewable sources are intermediate and unpredictable. We see everywhere, right? Now also the renewable sources are getting very decrease in this nowadays, and they are smart grid but balanced supply and demand dynamically. For this what we call renewable integration, I think my solution is, firstly I would go through the forecasting, because the short term prediction of generation and the load to guide dispatch, and storage management. In this storage management, the batteries were used in peak shaving and frequently support and balancing the with performance. And the advanced inverted function, like we have to use advanced technology and some advanced functional thing, right? So in that I'm gonna think the troop control and ice landing detection and the grid support modes. And we can demand responses. We can also see the demand responses, adjusting the consumer's usage to stabilize the grid. In this, and conclude my topics. Thank you.
I'm going to explain about cost and deployment considerations. Smart grid deployment requires investment in smart meters, communication infrastructure, and energy storage systems. A phased approach helps reduce risks, validate performance, and ensures a better return on investment. Pilot scale and optimization. Organizations should start a small pilot project to test system integration and performance. Once successful, the solution can be scaled more and more in future. Firmware and security management. Regular firmware updates, patch management, and secure key handling are essential to protect smart grid devices from cyber threats and maintainable reliable operation. So KPIs and performance measurements are safety, energy loss reduction, and demand flexibility help evaluate the effectiveness and reliability of smart grid systems. So how do we secure by the design? Security should be built into the system from the beginning through encryption, device authentication, and network segmentation to minimize cyber risks, as there are many cyber risks in the real world right now. Resilient architectures. Smart grid should include redundant communication paths and fail-safe controls to ensure to protect the privacy and to maintain operation even during network failure or operation failure. So the standards or interoperability for the smart grid systems are following standards such as IEC 61850, IEEE, and NIST ensures compatibility between devices and simplifies integration and supports future generation. Test, validate, and iterate. So this is a concept that we have studied in the previous SEM for IDT. Before large-scale deployment, systems should be tested using simulations, hardware in loop testing, and trials to verify performance and reliability. So the conclusion or the next steps to make the smart grid system better are it can improve reliability, efficiency, renewable energy integration. Successful implementation requires phased deployment, strong cyber security, and continuous monitoring and optimization. So smart grid technology is a transforming traditional power networks into intelligent, efficient, secure, and sustainable energy systems for the future. Thank you.